So welcome to the chemistry class. Today we will read what is ideal solution and what is non-ideal solution. First, what is the meaning of ideal solution? See the some example. Suppose if you take 20 ml of water and 20 ml of suppose alcohol. So what will the final volume? It will be 40? No. If this is 40, then it is ideal solution. Similarly, suppose if you take 20 ml of benzene and 20 ml of toluene, then what will be the final volume? Is it 40? Yes. So the solution, so what is the definition of ideal solution? The solution which obeys Raoult's law over entire range of concentration and temperature, this is known as ideal solution. Got the idea? You see, when water and alcohol if you mix, this is not ideal solution. Clear? Similarly, when you take benzene, toluene, ideal solution. Here I have written the example of ideal solution. You see, benzene, toluene, ideal. Chlorobenzene, bromobenzene, ideal. Ethyl bromide, ethyl chloride. If you take these two, so these are also ideal solutions. So ideal solution means the solution which obey Raoult's law over entire range of concentration and temperature. This is known as ideal solution. Clear? So what are the conditions for ideal solution? Condition means delta V mixture equals to 0. That means here you will add 20 plus 20, 40 will come. Not 41 or not 39. So that's why delta V mixture equals to 0. Second is delta H mixture equals to 0. Delta H means enthalpy, no heat energy evolved, no heat energy absorbed. Then this is called ideal. Then this is the actually main region of ideal solution, this part. AA, BB and AB, all interactions are equal. What is this? You see. Suppose you will take this example, lead benzene is A and toluene is B. So in benzene, this is non-polar, this is also non-polar. So in non-polar means which force of attraction is present? London force. So this is called AA suppose. Similarly, this is toluene. This is also non-polar. Let suppose its interaction is BB. This is also London force. And when we mix this, this is called AB interaction. That is the solution. So the solution in which the interaction AA, BB and AB, all interactions are equal, then it is called ideal. Similarly, you see come to this. This is polar, means here dipole. Bromobenzene, polar, dipole. And when you mix these two, also dipole interaction is present. Understood? So this is the meaning. So the solution in which AA, BB and AB, all interactions are equal, then it is called the ideal solution. So if it obeys Raoult's law, then Raoult's law all formulas are true. We have read P1 equals to P1 not J1, P2 equals to P2 not J2, Pt equals to P1 plus P2. Clear? So in class 11 we have read in gaseous state ideal gas and a non-ideal gas or a real gas. Ideal gas means what? The gas which obeys all the ABCD law, the CG law. Then this is called the ideal gas. But ideal gas is not present in the universe, but ideal solutions are present. Okay, so ideal solutions are here. So this is the meaning of ideal solution. Similarly, non-ideal solution, that means the solution which does not obey Raoult's law over entire range of concentration and temperature, this is called a non-ideal solution. So you see, first I told, suppose if you take 20 plus 20, if it will be 40, it is ideal. If it is not 40, then it is non-ideal. So that's why two possibility will come. Either it is 41 or it is 39. So that's why non-ideal solutions, these are of two types. One is called a solution showing positive deviation from Raoult's law, and another one is solution showing negative deviation from Raoult's law. Positive deviation means you see greater, all are greater. So when solution showing positive deviation from Raoult's law, okay, come to detail. So first one is solution showing positive deviation of Raoult's law. You will remember the shortcut is positive deviation means all are greater, 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 greater. So you see the theory is this part, AA, BB, this interaction is greater than AB. AA, BB, this interaction is greater than AB. Clear? Suppose we come to an example, positive deviation from suppose Raoult's law. Suppose if you will take one example, acetone and alcohol. Acetone and alcohol. So in acetone, which interaction? Dipole-dipole, polar. Alcohol, also dipole-dipole. Clear? But when these two mix with each other, acetone molecule breaks some extent of hydrogen bonding present in alcohol molecule. Alcohol also breaks some extent of what? This interaction in acetone molecule. So this is called AA interaction and this is called BB interaction. So when this mix, then it will come what? AB interaction. That's why AB interaction is less than AA and BB interaction. Hence what? Vapor pressure increases. Clear? Hence this is called positive deviation from Raoult's law. Similarly, negative deviation from Raoult's law means AA and BB interaction less than AB interaction. You see one example. Suppose this is one acetone, and this is suppose chloroform. Okay. Let's suppose this is AA and this is BB. This is also polar, this is also polar. This is also dipole-dipole, this is also dipole-dipole. But when they mix with each other, they form one new interaction, hydrogen bonding. So that's why in a negative deviation, all are what? Less than. Okay, less than. Here less than. Here also less than. Here also less than. Remember this because questions are coming. Write the difference between ideal and non-ideal solution. So this is the meaning. So solution showing positive deviation means all are greater. Okay. Delta H mixture greater than 0 means what? Endothermic. But when a negative deviation, all are negative. Clear? So both the solution does not obey Raoult's law. So if it does not obey Raoult's law, then what will be its graphical representation? You see, graphical representation. So first is positive deviation from Raoult's law. So last class we have read like Xi1 0, Xi1 1, Xi2 1, Xi2 0, and you see we have read last class like this. So this graph is true, this is P1 naught and this is what? P2 naught. So this graph is true when the solutions are ideal. But here are non-ideal. So positive deviation means all graphs are, you see, positive. Vapor pressure increases. That's why all graphs showing above positive deviation. But in a negative deviation, so when new interactions are set up, the less number of molecules are converted into vapor state. Thus, vapor pressure decreases. So its graph will be like this, means this is the original Raoult's law, and negative deviation means like this. All graph decreases. Understood? So this is the meaning of positive deviation and negative deviation. Clear? So when solution showing positive deviation, you will remember all values are greater than 0. AA, BB interaction is greater than AB. But in a negative deviation, all are less than 0. Okay, and AA and BB interaction less than AB interaction. That means when new interactions are set up, less number of molecules are converted into gaseous state, but here more number of molecules are converted into gaseous state. Both the solution does not obey Raoult's law. So remember like this: positive deviation, negative deviation. All are greater, all are less. Does not obey Raoult's law, does not obey Raoult's law. Interactions what? Decreases. Here what? Sorry, here interactions are decreases, correct? Here interactions are increases. Okay. So here the example, positive deviation, here negative deviation. Clear? Thank you.